Right now, you are hurtling through space. Depending on your location, you're moving at up to 1,000 miles per hour. We don't feel it because the planet, the atmosphere, and everything on it have been spinning together for the last 4.5 billion years. This ancient, continuous motion is the invisible foundation of our survival. If it were to break, the world would instantly become unrecognizable. If the Earth were to instantly stop, we would immediately encounter Newton's first law, inertia. An object in motion stays in motion. While the bedrock beneath your feet would come to a halt, the atmosphere and the oceans would not. They would retain their 1,000-mile-per-hour eastward momentum. Everything unattached would become a supersonic projectile. As astrophysicist Neil deGrasse Tyson explains, people would be flying out of the windows. Every man-made structure not rooted to the crust would be sheared off and destroyed in a split second. The oceans would violently surge sideways, creating catastrophic mega-tsunamis that completely dwarf any natural disaster in human history. Winds moving at 1,000 miles per hour would scour the surface, turning the atmosphere into a global catastrophic storm. A sudden stop is an instant inertial apocalypse. But we can look past the immediate carnage to see the hidden forces that shape our planet. What if the Earth slowed to a halt over several decades instead? This gradual deceleration lets us witness the true physical mechanics that dictate where our oceans sit and where our land begins. The Earth's relentless spin creates a massive outward pull called centrifugal force. This force pushes mass away from the planet's center, causing the Earth and its oceans to bulge outward at the equator. Because of this outward push, the Earth's equatorial axis is 21.4 kilometers longer than the distance from pole to pole. In our slow halt scenario, this centrifugal force steadily vanishes as the rotation winds down. That equatorial bulge is entirely dependent on motion. Without it, the planet's gravity begins a total rebalancing of the world's oceans. As centrifugal force disappears, Earth's gravity becomes the dominant force pulling on the surface. This heat map shows that gravity is strongest at the polar regions and weakest at the equator. Without the outward spin to hold it back, the water begins to drain away from the equator, flowing toward those high gravity zones at the poles. Over decades, this migration would submerge the northern and southern latitudes under hundreds of feet of water, while exposing the ocean floor near the equator. This proves that gravity, not the shape of the land, is the ultimate master of where our oceans sit. This is the final geography of a motionless Earth. The 4 major oceans we recognize today would cease to exist. Instead, the water pools into 2 massive bodies, a northern superocean and a southern superocean. What remains is a continuous supercontinent of newly exposed land, wrapping entirely around the Earth's equator like a dry belt. The atmosphere would reach a similar stasis. Without rotation, the Coriolis force vanishes, destroying the global weather systems that circulate heat and moisture. This lack of circulation would turn that new megacontinent into a permanent, uninhabitable wasteland. We navigate our lives on a spinning world and take its constant, reliable motion for granted. That 1,000-mile-per-hour spin governs the physical map of our planet. Rotation is the unseen architect that holds back the oceans and maintains the delicate physical balance required for life to exist. Without its relentless spin, the Earth as we know it would vanish, leaving behind an alien and hostile world.